There's a counting technique that comes up so often in counting and probability that we give it a name. It's called the multiplication principle, and I'll, through an example, give you a suggestion of why it works. Let's suppose you're getting ready to sign up for classes for the next semester, and you're going to take two classes. You're going to take one in business and one in philosophy. And you look at the schedule and you see that there's two business classes that you could take, finance and accounting, and then there's three philosophy classes that you could take, either ethics, knowledge, or history. So the counting question would be this: how many different combinations of these two classes could you take? So here's how I'm going to think about this. I'm going to start here. This is called a tree diagram. I'll start here, and my tree is going to go out to the right with the branches. Now I'm just selecting classes, so it doesn't matter in which order I take them. But suppose I'm going to choose the business classes first. So I've got two choices here, two ways to make this decision. I could take the finance class, or I could take the accounting class. Once I've settled on that decision, then I come to the philosophy classes. So what can we do here? Well, I've got three choices here. So I could take the ethics class, the knowledge class, or the history class. And the same down here. If we had taken accounting, suppose you choose accounting, well then you choose your philosophy class, so what could you do? You have three choices again. You could take ethics, you could take knowledge, and you could take history. So here's the combinations that we could take, and order doesn't matter here. You could take finance and ethics, finance and knowledge, finance and history. You could have taken, you could sign up for what? Accounting and ethics, accounting and knowledge, and accounting and history. So all in all, there are what? If you add these up, you got what? 6 possibilities? Now look how I can get that 6. If I look down here for business, there's what? There's 2 ways to make that decision. Then I look for philosophy. There's 3 ways to make that decision. How do you get a 6? Out of a 2 and a 3, you multiply. All right, so that's the multiplication principle. And it says that if you have, say, now here's a little bit of symbolism. If I have n1 ways to make the first decision, n2 ways to make the second decision, n3 ways to make the third decision, and so on, and then I'm going to make k decisions. So what it says is this. Don't let the notation foul you up. It just says, if you have this many ways to make the first decision, this many ways to make the second decision, this many ways to make the third decision, and so on, how many ways can you make all the decisions? We just multiply them together. And that's what we did here. I had, like this, I had 2 ways to make the first decision, and times, 3 ways to make the second decision, so I just multiply them together. So here's a simple example here. How many license plates are possible if each plate has 3 letters followed by 3 numbers? So here's how I think about these. I've got 3 letters, 3 numbers, so I'm going to actually draw this out. I find that when I do counting, if I draw things out, it just makes it easier for me to think about. So what I've got here is a letter, 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 number, number, number. Now how many ways can I make that first decision? Well, what goes here? A letter. I could choose any one of 26 letters, so I'm going to put a 26 here, right? That's the number of ways I can make the first decision. What's the second decision? Well, that's another letter. Now I can use repeated letters, so I still have 26 ways to make that decision. And then the third decision, what letter do you want here? Well, I could still choose any one of those 26. Maybe. There we go. And then you come to this fourth decision. Well, what is that? That's a number. Now I could use any one of the 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 ways to make that decision. Number again, I can put any one of the 10 digits here, right? I can use a 10 here, and then the same thing for that one. So what do we get here? This turns out to be 26 cubed times, well, I know that one, that's 1,000. So my calculator shows that that is 17576 and then 3 zeros. So what is that? That is about a little over 17.5 million license plates that would look like this. So the problems in this section, 5.4, they all deal with this multiplication principle, give those a try, and I've done examples on the videos of probably most of those for you. But instead of just going to the videos right away, you want to get pretty good at counting here. So it's important that you think about these problems for a while. These are counting problems. The counting and the probability problems, they require some thought. They may not just come to you. Some thought is required. So take your time on each one. Make sure that you try it first before you look at the answer.